Model natural gas liquid fractionation process. In this video, you will use the column input expert and column property view menus to define and configure the standard hysys column models. You will also learn how to review and interpret various outputs and results from these column models. In this video, a simple flow sheet consisting of a demethylizer column and deethylizer column will be constructed to recover natural gas liquids from a natural gas feedstock, which is a common practice in natural gas processing. This video includes the following tasks. Task 1. Define and run the demethylizer column. Task 2. Define and run the deethylizer column. Task 1. Define and run the demethylizer column. The first step of the simulation is to build and converge a demethylizer column, which you will model using the hysys reboiled absorber column template. The column input expert will be used to identify the input parameters required to fully define this demethylizer column. To start the simulation, you will find attached a pre-built case file containing all necessary fluid package details and inlet stream data. Click Open, then open Case, choose NGL fractionation starter file. The three streams will serve as the inlets into the demethylizer column. The demethylizer will be modeled as a reboiled absorber column template with 10 theoretical stages. Choose the reboiler absorber from the model palette. Open the column input expert view. Change the column name to DC1. Select feed 1 at the top stage inlet. Select feed 2 as an optional inlet stream, entering on stage 2. Select external duty stream as a second optional inlet stream, entering on stage 4. Leave the default number of stages as 10 and enter DC1 overhead as the overhead vapor outlet. Enter DC1 reboiler Q as the reboiler energy stream. Enter DC1 bottoms at the bottom liquid outlet. Click the next button to proceed to the reboiler configuration page. Here you can select the desired reboiler configuration. We will accept the default value. On the pressure profile page, enter a top stage pressure of 2275 kilopascal and a reboiler pressure of 2310 kilopascal. Keep the default reboiler pressure drop value of 0. Click the next button to proceed to the optional temperature estimates page. Enter an optional top stage temperature estimate of minus 19.2 degrees centigrade and an optional reboiler temperature estimate of 20 degrees centigrade. Click the next button to proceed to the final step of the input expert, the specifications page. In this case, no information will be supplied for the boil up ratio, so click the done button to exit the input expert mode. After completing the required steps in the input expert, it's helpful to review the information contained in the column property view menus. For instance, reviewing the connection page. You can see the column name, the outlet stream, the number of stages, outlet streams that were created in the input expert. You should also see that the column is labeled unconverged at the bottom of the property view window. This is because the proper amount of column specifications are yet to be finished and the column hasn't been calculated. You need to consider how many specifications are needed, meaning degrees of freedom, and which specifications to utilize. There are two primary forms from within the column property view that can be used for these tasks: the design monitor page and design specs page. While either option is acceptable, the design monitor page provides a bit more detail about the column calculation at large. Now double click the overhead product rate specification. Enter a value of 1343 kilogram mole per hour for the overhead production rate. Ensure that the overhead product rate has been selected as the active specification and then click the Run button. Once a column model calculates and converges, you can access and review results from a variety of different locations. We will consider three common result reporting options. The first option, Design Monitor Form. The listing of currently loaded specifications, whether they are set as active or not, always display the current value of any listed variable. That characteristics make the monitor form a quick, easy, but not necessarily in-depth form to use for reviewing results. The second option is the Worksheet tab. Much like on other hysys unit operations, the Worksheet tab displays conditions, physical properties, and compositional data for all attached inlet and outlets. The third option is the Performance tab. The Performance tab is arguably the most powerful reporting tool available when working with column models. You can use it to view information from inlet outlet stream compositions, component flow rates, and component recoveries to internal profile data. Separate tables and plots can also be generated for quick review or transferred externally for more detailed analysis. Although the column has converged, it's not always practical to use flow rate specifications to satisfy the required degrees of freedom. These types of specifications are strongly dependent on feed properties and can result in columns which are difficult to converge or that produce undesirable product streams when the column feed conditions change. A more flexible approach is to specify either component fractions or component recoveries for the column product stream. Return to the design monitor page of the dimethyl column. Click Add Spec button to create a new specification. Select column component fraction. Click Add Spec. This new specification will attempt to fix the mole fraction of methane in the DC1 overhead product stream. The specification value is based upon the vapor produced from stage 1 of the column. Remember that the Rebold absorber model doesn't have an overhead condenser. Therefore, the column overhead product is simply the vapor draw from stage 1. Change the specification name to C1 and overhead. Set the stage to stage 1. Keep the flow basis as mole fraction. Change the phase to vapor. Enter a value of 0.96. Add methane to components. The degrees of freedom analysis on the design monitor page of the column property view shows 0, even though you have just added another specification. This is because the original flow rate specification is still in place as the active condition. The new mole fraction specification is currently being used as an initial estimate and as not the active specification. Deactivate the overhead production rate and activate the C1 in overhead. This concludes the first task. Task 2. Define and run the de-ethanizer column. The de-ethanizer column is modeled as a distillation column with 16 theoretical equilibrium stage, 14 stages in the column plus the boiler and condenser. The objective of this column is to produce a bottoms product that has an ethane to propane molar ratio of 0.01. The de-ethanizer column will be designed to operate at a higher pressure than the demethanizer. As a result, you will need to insert a pump between the two columns to boost the DT1 bottoms stream to a proper pressure. Add a pump operation to the flow sheet. Set DC1 bottoms at the inlet stream. Name the outlet stream DC2 feed. Name the energy stream. On the worksheet tab, set the DC2 feed pressure to 2792. Add a distillation column to your flow sheet. Enter the column input expert. Change the column name to DC2. Set the number of stages to 14. Set DC2 feed as outlet stream at stage 6. Name the overhead outlet DC2 overhead. And the overhead liquid product to DC2 distillate. And the bottom liquid outlet to DC2 bottoms. Name the reboiler due to energy stream DC2 reboiler Q. and name the condenser energy stream DCT condenser Q. Click Next to move to the boiler configuration page. Keep the default parameter. Then click Next to move to the pressures page. Set the condenser pressure to 2723 and set the condenser pressure drop to 35 kilopascal. Set the boiler pressure drop to 0 and the boiler pressure to 2792. Click Next to move to the temperature estimates page. Set the condenser estimate temperature to minus 4 degrees. And the boiler estimate temperature to 93.3. Click Next to move to the specification page. Set the vapor rate to 317.5 and liquids rate to 0 and the reflux ratio to 2.5. Click Done. Move to the design monitor page. Verify that the degrees of freedoms are 0 and that there are 3 active specifications. Then click Run. Remember that the ultimate objective of the de-ethanizer column is to produce a bottoms product with an ethane to propane ratio of 0.01. You simply cannot just add on a specification for this target, as that would upset the degrees of freedom requirement. Only 3 specifications may be active, so one of the original specifications must be deactivated. Click Add Spec to add an specification. Select column component ratio. Rename it to C2 over C3. Set the stage to reboiler. Keep the flow basis as mole fraction and the phase as liquid. Enter a value of 0.01. For the numerator component, select ethane. And for the denominator component, select propane. Deactivate the overhead vapor rate and activate the C2 over C3. Using the options on the performance plots page, generate a few tables and the graphs of tray by tray properties in the DC2 column. For example, select composition, click view graph, click for properties to modify the displayed components and phases. You can do the same with view tables. This concludes our video. Thank you for watching.